Hey guys, I want to talk to you about factoring by grouping. Factoring by grouping has become more popular recently, so maybe you've seen it. Uh, it's definitely, I think, the best way to factor, not only just polynomials with four terms, but when we talk about trinomials as well in chapter 5.6. So give it a shot. Even if you think that your way is better to start, I'll show you some tips in this video that it's really nice to factor by grouping. And so chapter 5.5 is about factoring by grouping when there are four terms specifically. The idea is that you should group the first two terms together and then group the second two terms together as well. So if there's four terms, you can group the first two together and group the second two together. But the thing I want to emphasize most is that you use addition between the two groups always. After that, you can factor the GCF from each group. If this polynomial is actually factorable and you're doing things correctly, then they should have a matching factor. So then you can pull that matching factor out, and then then you should have a factored polynomial. But a good fourth step, which is optional, of course highly recommended, is that you check whether it actually works by multiplying it back out. So let me show you how this works. Let's say I have a nice polynomial like x cubed plus x squared plus 4x plus 4. There are four terms here. I want to factor this expression. So step one is saying group the first two terms together and group the second two terms together. So x cubed plus x squared go together, 4x plus positive 4 go together, and that big point of emphasis is make sure there's addition between them. Looking at just the first pair, you could take an x squared out, and you're left with x plus 1. Looking at the second pair, you could take a positive 4 out, and you're left with x plus 1 again. That's good because this is like the checkpoint. It tells me that 1, I'm doing things correctly, and 2, that this polynomial is factorable. From there, I see that they match, x plus 1 and x plus 1, so I can pull that common factor out, and then I'm left with x squared plus 4. So factoring by grouping is really nice because a lot of people would have not known how to factor this polynomial. And if I FOIL it back out, even if I just do it mentally, x times x squared gives me x cubed. 1 times x gives me x squared. Then 4 times x gives me 4x. 4 times 1 gives me 4. So I see that that is correct. But it could be more than just addition between them. You always have the addition between them regardless of what's happening. So if I change it up, maybe use more variables and have subtraction between the first two pairs, let's put a lot of subtraction in the problem. Let's make it something like 2xy minus 3x minus 6y plus 9. This has two variables, so that's a little scary, but what you see is there are four terms, and if I'm asking you to factor this, then you can use factoring by grouping. You put the first two terms together, 2xy minus 3x, those get grouped together, and then negative 6y plus 9 get grouped together. The 6 is negative, that negative belongs to the 6y, so I'm taking it with it. But there's no sign there if I do that, so I should group them with addition always. In the first case then, I could take out an x, and I'm left with 2y minus 3x. In the second case, I could take out a 3 from each of these, but anytime the leading term is negative, I also want to take out the negative with it. So I'm not just going to take out 3. I'm sorry, I've taken the x out here. So that leaves me with x times 2y minus 3. No more x. But like I was saying, I can factor a 3 out of these two, but anytime the leading term is negative, I want to pull out the negative with it. I'm pulling a negative 3 out of a negative 6. That gives me a positive 2y. And then I'm pulling a negative 3 out of a positive 9, so it leaves me with minus 3. If I've done everything correctly, which I almost didn't, but if I have up to this point, then they'll match. 2y minus 3, 2y minus 3, they have the same factor. I can pull that 2y minus 3 out, and then I'm just left with the x and a minus 3 to make up my second factor. Let me show you one more time so I can do it a little more smoothly. Sorry about that. Again, let's use multiple variables. Say I have let's do 4x cubed minus 3x squared minus 12y plus 9. I'm sorry, 12x plus 9. Then when you group the first two terms together, you're grouping 4x cubed minus 3x squared. You're grouping the negative 12x plus 9 together, and you're putting addition between them. Only thinking about this first pair, I see that there's an x squared that can come out of each of those. Leaves me with a 4x minus 3. Then I also see I can take a 3 out of each of these, but since its leading term is negative, I'm going to take out a negative 3, and that leaves me with a positive 4x and a negative 3 again. So that when I take that common factor out, 4x minus 3, I get x squared minus 3 left over. The x squared is first, the minus 3 is second. Minus 3 is second. So I just want to show you that this is actually pretty nice. Like, it seems like a long process for factoring, but the reality is that if you've done this a lot of times, then you can actually see the pattern. What I mean is this: 3xy minus 2x minus 6y plus 4. If this is the expression that I want to factor, then what I usually do is I could probably do this in my head knowing that I'm grouping the first two terms together. Because knowing I'm grouping the first two terms together, I already know that I'm going to end up with these two factors. From the first two terms, I could take out an x. That's what ends up here first. And then when I take an x out of the first two terms, that leaves me with a 3y and a minus 2. So I can already get half of the information from factoring just by asking myself what I can take out of the first two terms. And then what goes here is what's going to come out of these last two terms. So out of these last two, I can take out a negative 2. It's going to leave me with an x minus 2. Let me show you what I'm saying by actually doing it. 3xy minus 2x, when those get grouped together, I pull out an x. I'm left with 3y minus 2. Negative 6y plus 4, same thing. I put addition between them so that after I take out the x, I get 3y minus 2. After I take out a negative 2 here, I get 3y minus 2. So I can already see that the matching factor is 3y minus 2, and x minus 2 is left over. But this is what I got before I even factored by grouping. If you do factoring by grouping enough, you could factor instantly in your head without having to do all of the work. So give it a shot, practice it. I'll show you trinomials in the next video, so you can practice that as well. I really think it is the best method of factoring. So try it and let me know what you think.